Welcome along. So this is a recording of a presentation I gave at Autodesk University in 2016. The presentation is called 5 Pillars of Effective CAD Management, and my name is Paul Munford. I'm an application engineer with Greytech in the UK. So this presentation is really aimed at people who aspire to be a CAD manager. Perhaps they're not a CAD manager yet, but you can see how things could be improved at your company if there was one. Or perhaps you became a CAD manager kind of by accident, right? So nobody goes out to be a CAD manager. Nobody goes to college or university and says, I'd like to get a degree in CAD management. So for many of us, it's kind of a path we found ourselves getting towards there without really planning it. And for many of us, and I know there's lots of you out there, and I've been in this same position myself, you're doing all the CAD management tasks, but you're not getting the credit for doing them. So again, you'd like to improve your knowledge, improve your skills, improve your ability to do those CAD management tasks, maybe even get that title in the end. So we're looking at 5 key areas to attend to when we're supporting our CAD users to affect their productivity. Now, these are the learning objectives for this class. We always show these at Autodesk University. If you've been to Autodesk University, you'll know this, right? But if you've not been before, then there's so many great classes. So we always show learning objectives at the front of the class just to make sure that you know you're in the right class. Because if you're not, you never need to be in a class that's too advanced for you or too simple. There are so many good classes going on, you just politely sneak out and go into another class. So in this class, our learning objectives are just to discover the 5 pillars of effective CAD management, learn how to manage these 5 key areas to improve our productivity, discuss how to prioritize the planned improvements, and learn how to plan a phased improvement over time. So where did this presentation come from? Well, I started out my career as a carpenter. I actually studied scenery design and specialized in construction management. So I spent the first 8 years designing and building scenery for theatre, TV and film. And I kind of worked my way up to the construction manager role and then eventually the project manager role. And back then I did all my drawings by hand. I'm still very proud of this. This is my front piece for my portfolio. I used to take around there to pitch for jobs and try and get work as a draftsman. And that was great work, but a little bit unreliable. So eventually I went for a full-time job as a drafter, and I had to learn this thing called AutoCAD. I spent 1 hour a week for 12 weeks at night school learning AutoCAD, and managed to get myself a job. So I used AutoCAD exclusively for drafting for 4 years, and then I picked up Autodesk Inventor. And I spent a further 4 years drafting with Autodesk Inventor before finally becoming a CAD manager and spending the last 4 years of my career as a CAD manager, implementing Autodesk Inventor within a company that made high quality furniture. And if you want to know about that, have a look at a presentation I gave last year at Autodesk University called 5 Mistakes of a Rookie CAD Manager. Now, I'm now an application engineer. I've been an application engineer for a company called Greytech in the UK for a year. And my job is to go out and help CAD managers to get better use out of their CAD software. So I've seen a lot of the themes that I've considered as a construction manager, project manager, CAD manager, and now CAD consultant, application engineer. So these 5 pillars really came from the fact that I'm lazy. I do not want anything to be any harder work than it really has to be. So over this the last 20-year career, I've constantly been looking for themes. I've been looking for the bigger picture. I've been looking for where can I use my time productively that will have the greatest effect on what I'm doing. So I'm lazy, but I'd rather spend an hour doing something now than have to spend 4 or 5 hours fixing it later. And that's really what this presentation is all about. It's a culmination of those general themes, those topics that I've been able to put together. And I figured this might be helpful to you guys, right? So I put this all together in a presentation. I'm hoping you'll find it useful. So the first topic. The first topic is going to be around hardware. And the reason I put this first, because I think hardware is the easiest investment you can make in your CAD office with the quickest return. So if your team are experiencing hangs, if they're experiencing crashes, if they've got downtime, well, we want to eliminate that. And we can eliminate that by getting them better hardware. And the reason I say this is one of the easiest investments to make is because it's a cash investment. Now, you might find that your boss is saying, oh, I don't have enough money to invest in this sort of stuff. I'd like to have a think around that. If your company is successful, they'll be making a profit. And if your company is successful and they're making a profit, they won't want to spend that profit on tax. So they'll be looking for things they can invest in that they can take off that tax bill. So I recommend that if you're struggling to find the investment within your company, one of the things you can do is go and talk to your accountant. Now, I'm not saying go behind your boss's back, but I'm just saying, get a picture of where the finances of the company are. In the UK, we have something called depreciation. And really what that means is, instead of buying a computer and writing it off against the tax bill this year, you can write a bit of it off against the tax bill over the next 3 to 5 years. So the accountants are always looking for investments they can make so that they can offset things against tax. So it's worth getting that picture. The other thing that's worth mentioning is that you might find that your investment in hardware, you may find your investment in hardware, you may think it's an awful lot of money, but when you go and speak to your accountant, you might find it's actually something the company can afford in cash. It's quite surprising. So the reason your boss may not be willing to invest in hardware may be one of middle management. He doesn't want to put his neck on the line and have to be the one to justify this cost. Okay, so why don't we help him out? Let's talk to our boss. Let's be open. Let's say, look, we are wasting time. We are spending non-productive time sitting, watching the computer, watching the little thing go around on the computer. We're not working. We can eliminate this with an investment. What can I do to help you put a proposal together so that we can get this through? Okay, so really it's relatively easy to calculate the potential gain from buying new hardware. The amount of time that you're wasting times the labour rate of your company equals the gain that we could achieve. So as an example of this, 1 hour per week wasted, 48 hours of working weeks per year. If your labour rate's $40, that's $1,920 you could potentially save if your hardware supported you better. So that's okay, isn't it? And you can get a pretty good computer for that amount of money. I just did a quick filter here on Amazon for that sort of price range. This is all really good kit. You don't need to spend that much in order to get a return on your investment. Okay, so here's the key thing. In order to put a proposal together, we really need to measure how much wasted time that we've got. So we want our proposal to be honest, and we want better do our proposal to be accurate. So we're putting figures together for our bosses that demonstrate the problem. It's not something that could be considered sort of knee-jerk reaction or kind of an emotional reaction. We want to be able to make this into something that is a financial business plan that we can give to our bosses so they can look at it in terms of it being a rational investment. So here's the key thing. How do we measure wasted time without affecting the thing we're measuring? Now, I tried this in all sorts of ways as a CAD manager, and I found that if I gave my guys a daily worksheet and said, kind of fill out what you're working on, or fill out when you've got wasted time, downtime, or hard work time, after a couple of weeks, even I forgot to do it. So we needed a simpler method of measuring our wasted time. And in the end, well, this is what we came up with. Really simple. A jar of counters on the desk. If your computer hangs, just take a counter out and stick it in your pot there. And so once a week I could just come along and count the counters. Okay, I appreciate this may not be hugely accurate, but really how much accuracy do we need? We just need to demonstrate that there is an issue here that could be fixed. And so this was accurate enough for us. Okay, so we talked about depreciation. So make sure you understand depreciation. Make sure you understand the value of your budget over time, but also budget for future upgrades, right? So if we're going to go to all this work to put a specification together, put a proposal together and get a proposal signed off. We don't want to be going back in a couple of years having to do this all over again. So we're going to put a budget in for hardware yearly with a 3 to 5 year plan, aiming to replace the hardware as the depreciation runs out on it. And of course, the hardware we're supplying for CAD stations could easily be repurposed somewhere else in the company. There's a trickle-down effect. Everybody gets a better computer, and then the worst computer in the company can be kicked out at the other end. Okay, so I thought I'd spend a minute just talking about how to specify a CAD station. I have to admit I'm not a hardware geek. When I first began using AutoCAD, I was actually using a Apple Mac computer, and I had to sell that and buy some parts to improve my wife's PC computer or Windows computer, so I could run AutoCAD on it. So that was my first introduction to CAD hardware, and I haven't got much more excited about it since, but it's something we need to know, right? As a CAD manager, we need to know about the engines our CAD stations are running on. So the first thing is operating system. You may be working on Windows 10. I've heard pretty good things about it. A lot of people are very pleased. There are still updates coming out which are causing compatibility issues with Autodesk software. That's a bit of an issue. Windows 7 was very stable. Windows 8 not so hot on Windows 8. So the first thing to decide if you're specifying a CAD station, can we buy it with Windows 7 on it? Do we have to buy it with Windows 10? Whatever you choose, make sure it's a 64-bit operating system, otherwise it's not going to be able to address as much memory. So definitely 64-bit. Personally, I'm recommending right now Windows 7, but Windows 10 is okay. The key thing for me is to try and make sure that all my team are on the same operating system. That just makes life a lot easier for debugging, support issues, but also if we want to roll out this software, we want to be able to push new updates of AutoCAD or Inventor or Revit out to multiple workstations. It's really helpful if everybody's on the same operating system. Okay, so I'd be wary about moving to Windows 10 if it's just 1 or 2 users. If you're replacing everybody's workstations, no problem. So the biggest bang for your buck, I think, is an SSD drive. And we've seen this have a huge impact on the productivity of my own particular CAD team, but also the customers I work with. So an SSD drive is basically a solid state drive for your operating system. So you're running your operating system off a solid state drive rather than the slightly older optical drives. What's fantastic about that is your whole operating system boots that much faster and runs that much faster. So it gives a lift to everything running on your machine, including your CAD software. So we've all had that experience, right? When we come to work and we turn on our computer and then we go off and make a cup of coffee, and when we come back the computer's ready to work on. SSD drives boot almost immediately, so you're straight into work. That's less time wasted. And as I mentioned, everything gets a lift, everything runs a little bit faster. If you need to open an Excel spreadsheet in the background, if you need to open a database in the background, all those things run faster and it just gives everything a lift. So I definitely recommend SSD drives. SSD drives had a bit of a bad reputation when they first came out as being a little unstable, and many people would keep an SSD drive for their operating system and then put all their data on an optical drive. And that's fine, but many of us these days have most of our data stored on the network anyway, rather than on a local drive. And SSD drives have got a lot more reliable, so it's less of a consideration these days. It's less of a problem. I think the key thing is that your data is backed up, so there's nothing on your local PC that isn't being backed up to the network somewhere. RAM. Lots of RAM, as much RAM as you can get. Okay, so RAM is the memory that your computer can address at any one time. So the more RAM we have, the more data it can address. So realistically, the way I think about this is if I've got a large model and all my model can be held within the RAM, then my CAD software can be operating on the entire model at once. If the model is so big I don't have enough RAM, then my CAD system is going to have to bring some of the data onto the RAM and leave some on the hard disk, and then it's going to have to swap those in and out. That swapping in and out is called your page file. You can tweak your machine to make a bigger page file, and you can also include your own, if you separate your partition off your hard drive, you can actually put one of your partitions as being your page file, and that will write a lot quicker, particularly if your page file is on an SSD drive. But realistically, if we've got enough RAM to support all our model, then that's not an issue. So as much RAM as you can get. Don't think I'll have 8 gigabytes of RAM, I can put more RAM in later. Just try and get it all in there as soon as you can. It makes a huge difference. It's going to make you much more productive. Processors. So most CAD software is kind of old. It's been around for a while, so that it doesn't run on multi-threading. There are some processes that do run on multi-threading. So rendering will benefit from multi-threading. Simulation will benefit from multi-threading. But generally speaking, your CAD station is going to use one CPU, and it's going to use it for doing all its calculations. So if you want your CAD software to run faster, you need a faster CPU. So in terms of our processor, faster is better. Multiple cores is not a problem, but I would always put a faster processor ahead of multiple cores. Okay, if you get the choice, faster processor ahead of multiple cores, unless you're building a render station, it's a slightly different thing. And last thing is your graphics card. You do need one. So your graphics card is the part of the software that will render your 3D model on the screen. So your processor is doing all the calculation, all the math to work out what your 3D model should look like. The graphics card is going to put it on the screen. However, many graphics cards these days have a GPU, a graphics processing unit. Some of them even have multiple GPUs. And so they can be used to speed up your CAD station as well. So recommend a graphics card running Direct3D 10 or 11. You can check out the recommended graphics cards, the ones that Autodesk recommend, the ones that they've tested. There's a website for that, and I'll give you the link in a moment. So you can check out what Autodesk recommend, and also there's recommended drivers. Okay, so the driver that comes with your graphics card may not be the best driver for your CAD software. So you can take your graphics card details, you can go to the Autodesk site and you can look for the recommended driver on the Autodesk site, or you may even go to your driver's own software download site and see if they've got a recommended driver for your software. If they have one, use that, because that's going to be tweaked to suit your software. It's going to run much better. Okay, and don't forget about your network speed. So if you're using large amounts of data, particularly something like Revit or Inventor, lots of data stored in the server, you're going to be writing files backwards and forwards all the time. So don't forget to give your network a bit of love as well. Look for optical fibers, make sure that all your hubs are running fast as they can, and make sure all of that is being looked after. Otherwise you may have a super fast desktop or laptop workstation, but it's spending ages getting the data on and off the network. So here are a couple of links. If you're specifying a CAD station, look for the system requirements on the Autodesk site. You can find the graphics hardware recommendations there as well. And I've given you a link here to Catalyst magazine. Catalyst magazine put together a fantastic blog for specifying workstations, gone into way more detail than I've got time to give you here. But particularly if you're specifying something that's not an ordinary CAD station, like a render station or something like that, check this out. It's a really good resource. But there's a simple shortcut if you're specifying a CAD station. Instead of having to do a whole bunch of research and trying to find out what's appropriate for you, ask your reseller. So I did this when I was a CAD manager. I asked my reseller to specify a CAD station. I then took that specification out into the market and I got competitive pricing. Now I actually did buy from my reseller in the end, and the reason I did that was because my reseller offered to pre-install all of my Autodesk software in those machines before I received them. And that meant I got my downtime for turning these machines around to about half an hour per user. Take the old machine away, plug the new one in, ready to go. So that's another little idea for how you can reduce downtime when you're swapping out your hardware. But ask your Autodesk reseller for help. That's what they're there for, and they won't charge you for it unless you're actually going to buy something from them. So I thought I'd throw in a couple other little tips here. So let's say you've already got your hardware up to date, or let's say you've just reached a brick wall and there's absolutely no way you're going to get the finance for some new hardware. Well, there's a couple of things you do might be a little bit cheaper. So a second monitor. How much more productive do you think a second monitor would make you? So I've got a figure here, and it's off the Monitor website, but well, let's just see what you think of it. So they would suggest that a second monitor could make you 12% more productive. Now, I reckon that's about an hour every day. So you could save an hour every day just by having a second monitor. And bearing in mind you could get a second monitor for like $100. I mean, that's really that's not that difficult to justify, surely. Now, from personal experience, I think a second monitor is really helpful. The amount of time we spend flicking backwards between documents, so we can have a document we're referencing on one screen and our CAD work on the other. It's awesome. An interesting conversation. A lot of people these days are running 3 monitors because I'll have another monitor out there for Outlook as well. So interesting. So how many people have got one of these? So this is a 3D mouse. And again, in terms of productivity, I've got this from the 3D Connection website, but they think the 3D mouse could make you 21% more productive. So that's an hour and a half a day you could save yourself just by using a 3D mouse. Now, I use one of these 3D mice for working with Inventor. I find it absolutely invaluable. I bought mine at Autodesk University for like $60 in 2008. I wasn't keen actually at first. I tried one out on the stand. Didn't really work for me, but they very cleverly put one in all the classes and all the labs. So in the labs I could go and have a little play, and I got used to it and thought that's really good. And I brought it back to the UK and used it about 4 years straight, and then it died and it packed in. So I had to, I kind of panicked. I was used to using it by then, so I immediately went and bought another one, only to find that my original one started working again. So it's still working now. It was $60, and it's lasted for what, 8 years. So it's these are really high build stuff, really good quality. I'm not getting paid by 3D Connection to say that. I'm just a fan, and I think they're definitely worth having. And again, $60. You should be able to find a way of spending that in your company for that sort of productivity gain. Anyway, it's enough about hardware. Let's move on to the next one. So I wanted to talk next about content libraries. So I've put this second on the list because I think it is the second most effective thing you can do to make your team more productive is to have content. So I would say that when we use CAD, it's not because it's better than hand drafting, right? Because I used to draw by hand, and I used to really like my hand drawings. I used to like being able to do shading, sketch out a little perspective view. I really found that fun, and I like the fact our drawings had personality in them. You could see who drew what. So I would say we're not using CAD because it's better. And we're not using CAD because it's quicker, because some of those old boys could really knock out their drawings, right? So I would say that we use CAD because of copy and paste. Right, so when we were drawing by hand, if we wanted to make a change, we would have to rub that change out, or even cut a piece of the paper away and put a new piece of paper in to make the change. Making the change took just as long as the original drawing did. Right, there was no time saved. Maybe you could trace over the top, but there wasn't really an awful lot of time saved. Now, I believe the reason we've adopted CAD over the last 30 years is because it's so much quicker to make changes. Well, we can edit stuff, and we don't lose anything in the quality. We can edit, we can delete, we can add, and we can copy and paste, right? So what would be quicker than editing a CAD file than copying and pasting in some content we've already prepared? And that's why I think content libraries are so useful, because if we have content that we can reuse, that's always going to make us more productive. It's always going to allow us to get our work done that much faster. So I love this picture. I can never work out whether this is a huge drawing or whether these are tiny, tiny draftsmen. I love the idea that I could leave my T-square and my straight edge out overnight and these guys would sneak in and do my drawing work for me. But it's not just about drawings, right? So when we create content, we're not just creating content in order to create a drawing. When we create our content, we're thinking about creating content that it's not just 2D, our drawing, it's not just 3D, right? So the advantages of 3D, be able to do fits and clash detection, all that kind of stuff, really understanding that it works. But we can also capture data. And this is absolutely key. So when we create our content, we're not just capturing a detail, we're capturing the data that goes with it. And for me, when I started using 3D CAD, one of the things that kind of surprised me was that I didn't create my drawings any quicker. And I used to get a lot of flack from the project managers. Why are you using this flashy 3D CAD, but you're still not getting your drawings out any quicker? What's that all about? And what I really realised was that no, I wasn't getting my drawings out quicker, but because I'd captured data in my 3D model, when it came to processing my drawings for fabrication, I had a lot less work to do. So in the old days, I'd do my drawing, and then when the drawing was signed off by our customer, we then need to put it into production. So I'd take out my hole template, and I'd put my drawings out, and I'd draw a little hole, and then I would write a number in it, and then I would go to my carbon copy pad and write that number, and then I would say, so this part number, and then write out the details about that part. So that process could easily take a week for a large design to better process it and better produce a procurement list, a list of all the raw materials needed to buy, a list of all the hardware we needed to buy, a parts list so that the guys on the shop floor could cut all the parts up, and then the drawings which would show them where the parts were used and how the parts need to be put together. So that was a week's work, but that was a week's work I didn't have to do when I built my assemblies in 3D. I'd captured all that data in the process of designing it. I'd saved myself a week, but more importantly, I'd saved myself a really, really boring task that I didn't want to do in any way. And for the manufacturing team, they got a week of additional time in production to either start that job earlier or be able to move these jobs around, right? So it was a win-win for everybody. So I just wanted to give you a couple of tips here on creating content libraries. So the first tip is just start. Okay, so the biggest problem that I believe people have with content is they just don't get the time to make the content that they would like. A lot of the time for us CAD managers, we're very specific about the way we want things done. We want things done to our standard. Sometimes we just don't have people that we can trust to do things in the way that we'd like them to be done. So we end up doing it all ourselves. And we're busy, right? So we've got billable work to do, we've got CAD management tasks to do, there's meetings to attend. When do we get the chance to make some library items? So my advice is just start. Just make one. Make one block. Make one part family. Make one Revit family. Just make one. You've got to make a start. You've got to start somewhere. And every library item you create will save you some time. And it's time you can use to create more library items. So it will build. It will build over time. And if you've got 20 minutes to be able to put some content in your library, it's going to help everybody work a little bit faster. It will pay you back. So just start. That's my main tip. Okay, next section, software. So when we talk about managing software, there's really two elements to this. There's managing the licenses, right? So that's the practical day-to-day of actually installing the software, getting it licensed, getting it up and getting it running, but also managing the costs. So this would be more like a yearly or even a 3-yearly job of procuring your CAD software, making sure that we understand the costs. So let's just begin by talking about managing licenses. So you should all know by now that Autodesk have changed their offering. So we used to buy a perpetual license of Autodesk software. A perpetual license means we don't actually own the software, but we own a license to use the software in perpetuity, right, forever. So the idea is as long as we've got a computer with a compatible operating system on it, we can install our CAD software and we can use it for as long as we like. So we paid a one-off fee for that license. In most cases, it was a lot of money. We paid it up front. And then we also had something called maintenance. So a maintenance subscription. And the maintenance subscription, all that meant was instead of having to pay for an upgrade next year, we'd pay maintenance subscription in advance and we'd get the upgrade thrown into our maintenance. So maintenance subscription was all about kind of cost fixing. So if we said, well, I think I can wait 3 years before I upgrade my CAD software, you could do that, but you might take a little bit of a gamble and you don't know how much the CAD software is going to cost in 3 years' time. So you don't know if you're going to be able to afford it. In most cases, it was much, much cheaper to pay maintenance subscription, and you could pay maintenance subscription in advance for 3 years, and you would know therefore how much you were going to spend on CAD software for the next 3 years. You were fixed, and you would definitely get, for the next 3 years, you would get an upgrade every year to the latest version. So for companies that had cash, that had a good cash flow, that had cash in the bank to spend, that's kind of a good way to spend it. And again, that's something we can put against depreciation in many cases. Now that's changed. So now we have rental licensing. And the difference is rental licensing, you pay a much lower cost up front. But you don't pay a maintenance subscription, you just pay a continuous subscription forever. The main disadvantage being if you stop paying your subscription, your software stops working. And we don't have a choice. Autodesk have taken away perpetual licenses. If you have a perpetual license, Autodesk will honour it. And as long as you pay your maintenance subscription, you can keep that perpetual license running. But if you want to buy any new licenses, you cannot buy perpetual licenses anymore. They will be rental. So as CAD managers, your new license management tool is the subscription center, the Autodesk subscription center, which you will find by typing in manage.autodesk.com into your browser, and it will take you to this page. As the license administrator for your company, you can use this portal to download the software, find out what your serial numbers are. You can create users, right? This is an important step. So for each person who works at your company who wants to use CAD, you will need to create a user account for them in your company account. They will need to have an Autodesk account. They may even need to set up themselves because they'll have to have a password. And that Autodesk account should be using their company email address. Okay, so you can use that same company email address to create them as a user in your company account. And then you can allocate them a license. So in your rental license pool, you allocate a license to that user. When that user logs in on their software will ping the Autodesk server. The server will look at their company account that they belong to. It will find they have an acceptable allocation, and then it will tell the software it's allowed to work. Okay, so that's how that works now. The last thing you can do is you can manage cloud credits. So cloud credits are used for things like rendering in the cloud, simulation in the cloud, all that kind of stuff. A cloud credit is currently set at about $1, but what you get for that dollar depends on the process you're using. So this is where you can manage. I think you get something like 100 cloud credits when you open an Autodesk account, a free Autodesk account. If you're a subscriber, you get more, and you can buy more through the portal as well. So this is where you'll also do this. Okay, so that's managing your licenses, managing costs. So this is kind of key. So when we bought perpetual licenses, let's say they were £5,000 in advance for a seat of Autodesk Inventor. That's quite a lot of money to spend, and so you'd want to negotiate and get the best price possible on that. Now we're buying subscription licenses, rental licenses. We may be spending a few $100s a month. The Autodesk reseller you're buying that software through is not going to make the profit they used to make up front. They're not going to make that now for about 4 years. It's going to take about 4 years of you paying subscription until you've paid the same amount that you used to pay in advance. And of course, you don't have to pay subscription. You can stop that subscription at any point if you don't need that license anymore, and that's it. So Autodesk resellers are not going to be willing to negotiate on this. And if you buy direct from Autodesk, you're just buying through a website, so you can't negotiate with them either. So you're going to find that buying your software is no longer a negotiation point when you are working with Autodesk and their resellers. So my advice is think about training, think about hardware, think about support, think about all the other things you need from the Autodesk reseller, and really put a package together, and then you can look for a good deal. Okay, so try and put that together with your subscription updates and try and put together a good deal. That will get you the best price. But don't ask for a discount on software anymore because I think they'll be unwilling to give you one. So just to round off, perpetual licenses, they were a high upfront cost, but they were ours forever. We did pay an additional maintenance subscription in order to have the latest version every week, and it was locked to your PC. So the license was installed on your PC. If you wanted to move that license, you had to physically use a license and install tool, and then you could move that license to another PC. Rental licenses are a low upfront cost, so you can get the software, you can try it out, you can run it. If you don't need it, you don't have to have it. If you've got people coming to your work for a while, kind of interns or contractors, you can buy them a license, and when they're done with it, you just stop paying for it. So that's kind of cool. So it's yours, but only while you pay. If you stop paying, that's it. You don't get to use the software anymore. There are no additional costs. There's no additional maintenance subscription or anything to spend. And also, this is key. I don't know if I made this clear enough earlier. You can use it on any PC. So you can install the software on every PC at your company, And when the user logs in, the license is tied to that user. So that user can log into the computer, use the PC. When they're finished, they log out, then go to any other PC, log in, and the license follows them around. Okay, so it's again, it's also kind of helpful, maybe give you some flexibility. So the license lives on the Autodesk server, so you do need to have internet access, but the software will only ping the Autodesk license server once every 2 weeks. And in fact, if it can't ping the Autodesk server, it will have another 2-week period in which it will continue to try and ping. It won't actually cut your software off for 4 weeks. So as long as your computer's connected to the internet once every 4 weeks to ping the server, make sure the license is still active, you're good. So for most of us, that's not going to be an issue. Next section, standards. So I'm really keen on CAD standards, but it may not be what you think. For me, the real thing about CAD standards is that CAD standards allow us to work more efficiently. So I don't believe in CAD standards because I want all our drawings to look the same. It's an advantage, of course. It's good for the workshop if there's consistency in the way our drawings look. That's going to help them to read the drawings, get their head into the drawings quicker. And it looks more professional if all our drawings come out looking the same. It looks more professional in front of the customers. But in terms of payback to the company, in terms of value to the company, in terms of putting money on the bottom line, CAD standards allow us to work more efficiently. And the reason for that is it's about choice, actually. It's about less choice. So if your CAD users are sat ready to do a new drawing and they start thinking, well, what font should I use on this drawing? Well, that's really not what you're paying them to think about. And they're spending time thinking about something which is not a non-value add to the design they're working on. So what we really want to be thinking about is, can I make this product more efficient? Can I reduce the amount of material? Can I reduce the amount of machining? Can I reduce the cost? Whilst maintaining the quality that we've sold to the customer, of course. Now that's the kind of stuff your company's paying you to do, because that will save them cost when they fabricate or manufacture this item, which is going to go to the bottom line. Paying you to think about fonts and line weights and line styles, they're not paying you for that. So if we can have a standard, then we can make it easy for people to use that standard. People can just get on with it and be spending their time on more value-added tasks. Now, this is one of my favourite sayings here. This is Mark Kiker, who also speaks at Autodesk University, and is well worth going to see if you've got the time. Don't turn a people problem into a technology problem. So when we're standardizing, it might be tempting to go straight for, I'll write my standards document and then I'll put some tool palettes together, or then I'll put some templates together, or then I'll put some iLogic code together. Now the key thing here is that if people don't agree with the standard, if people don't subscribe to the idea of having a standard, then they won't use your standard. So standardization really is about change management. It's not really about a document like a 40-page CAD management document, and it's not about tool palettes and all that sort of technology. It can deploy a standard. If people aren't working together as a team and they don't understand the benefits of the standard, they won't use it. So we've got to deal with that first, right? That's what we've got to tackle first. So if you're looking to improve your CAD standard, or you're looking to implement a CAD standard into a company that doesn't have one, the first thing you need is support from management. If you don't have the management backing, it's very easy for people to say, I'm not doing it. There's nothing you can do about it. So the first thing is to go to your boss, as high up in the company as you can get, and explain that standardization is not about draftsman's OCD. It's a business case, and we're in the business. We're reducing the amount of time it takes us to create our drawings, whilst also increasing the value of our designers and engineers because they spend more time thinking about the right things. Okay, put that case to management, get their support. Management don't need to do much about this. All they need to do is make it clear they're supporting you. And if you've got that support, that's really going to help you with the next stage. So the next thing you need is support from the users. You need support from people actually going to use the standard. So my tip here is not to simply write your CAD standard out and then go and tell everybody they've got to comply to it, but actually spend a bit of time with the users, getting them into groups. Time is the key word here. We probably don't want to put a lot of time into this, but it's going to take time for people to change the way they work. So get them into a group, not just the CAD users. Bring together the people where they get their information from, sales, design, engineering, all those kind of people. Bring together representatives of the group, their internal customers, where their work's going, manufacturing, CNC, site installation. Bring those representatives of those groups together and talk about the process, the current process. How do we make the process more efficient? Could CAD standards help us get there? Okay, so it's key to kind of get that talk going, get that debate going. You can make it clear that it's not a democracy, that you're not going to vote on this, that as the CAD manager, you've been asked by management to fix this, and you're going to make the decisions. But you're not going to make the decisions without involving people and making sure that they understand why you've got to have a CAD standard, and that you understand that your CAD standard has to support those users. Okay, so have that debate, have that discussion, keep it going. And one tip here is that when you have that first meeting, set a goal for the next meeting. So you can say, we're going to have this meeting here, we're going to discuss this CAD standard. When we come out of here, we're going to have agreed what we're going to do, how we're going to move forward. And we'll have a review of this in 3 months' time. And the key thing for telling people why you want that review is because you're going to ask for their commitment. So you're going to say to them, I need you guys to try this out. I need you guys to work with this. I need you guys to actually use it. And you will have your say. When we meet again in 3 months' time, you'll have your say on what's working, what's not working, what we might need to tweak to make sure this implementation is suiting you. Okay, so the reason why you're asking them to commit is because you don't want anybody undermining your CAD standard by not using it or by actively going against it. So you need a commitment from people to actually give it a go and really try it out, because you've got the confidence your CAD standard is going to be good, right? It's going to be helpful. So you know if they try it, they're going to like it. But you've got to get them to try it. So we need that commitment. Okay, so setting a goal in the future means instead of them complaining about it or constantly coming back to you about it or feeling like they haven't got a voice, you've got an opportunity to say, I want to hear your feedback, but we're going to do that in a meeting in 3 months' time. Okay, so set that meeting, make sure you have it, but ask for that commitment. And the key thing when we're doing all this standardization is to focus on the goals. So it could be quite easy to get into sort of semantic debate about whether our lines should be one color or another color. Should we do all our annotations in blue? Should we use this font or that font? That's really kind of going to wear you down, because actually that's not important. Actually, it doesn't matter what font you use as long as you're consistent. So really the goal is to support our business process at the company to reduce the amount of time it takes us to create our drawings and increase the amount of time we spend on engineering tasks, right? So if that's the goal, every time somebody comes up to you to say, shouldn't our CAD standard be like this? You can say, how does that fit our goal? Please explain to me how that's going to reduce the amount of time it takes us to create our drawings or increase our value on as our drawings get downstream. If they can demonstrate to you that their idea is going to save time, you need to listen to them, because that's a good idea. That's going to be really helpful. But if they're just coming to you because they've got not an idea but an opinion, in my opinion we should use a different font, then that's actually not helpful. So you can cut that down quite quickly by saying, that doesn't suit our goals. I don't see how it's going to save us time, not a discussion worth having. Okay, so for me, I actually implemented BS 8888, which is the British Standard for Technical Drawing, not because I thought it would make our drawings look nice, not because I thought it was the best standard in the world, but because it was not my standard. It was neutral, and I could hold that up there and say, this is the standard, and then we could tweak that standard to suit our company, but we only tweaked it when we said our company needs something different to what's in the standard, or there's a business case for improving against the standard. And I only let people deviate from the standard when they could prove to me that it met our goals. Okay, so focus on the goals. It gives you something neutral. So instead of it all being on you and focused against you, we get everybody focused on the goal instead of making it personal and making it semantic. And the key thing here is you have standardization, you can have automation. Robert Green, who's also another fantastic speaker at Autodesk University, said the easiest standard to deploy is the standard nobody knows they're using. Okay, so once we've got standardization, then we can have automation, then we can have templates, then we can have tool palettes, then we can use iLogic, then we can start building up standard families. Okay, so we make it easier to use the standard than not to use the standard, and then we get a high level of compliance because people don't even know they're using it. But we can't have that unless we have buy-in, otherwise people will work around it. Okay, let's talk now about training. So training is also extremely important. But I guess you've all seen this, right? So what if we train people and they leave? What if we don't and they stay? Right? So we know that training is important. You may have also heard this one. We trained them in our CAD software when we bought it. Why do we need to train them again? So why do we need more training? Well, there's some key reasons why I think training and constant training is kind of important. Firstly, we need to break our routines. So we've all done this, right? We've been working in a piece of software. We've got to get a set of drawings out. We find a way of getting them out the door, and then, well, we just keep going that method, and we never actually stop to think, is that the best way of doing it? Right. So training can allow us to break ourselves out of our routines, try different elements of the software, try different techniques, maybe even use additional features. Right. So this is stuff we've paid for. But if we've never got around to learning it, we don't do it. And maybe we find a way of doing it. We find a workaround. Maybe there's an easier way. We just haven't had the time to sit down and work it out. So we need training to make the best use of our investment in CAD. If we haven't had training to use our CAD software effectively, we're not going to be using it effectively. And we're kind of cutting ourselves short of that investment. But it's not just CAD. So whenever we use CAD, we never use CAD by itself. So we also use CAD in the context of our company, in the context of our industry, and so there will be things we need to learn about other than CAD, and that's also very important. So we might need to learn about our CAD software. We also need to learn about techniques for using our CAD software. So in Inventor, you may have heard of top-down and bottom-up, skeletal modeling, multi-body modeling. They're not tools, they're all techniques. They're all different ways to use Inventor. And then outside that, we may have industry terminology we need to use. We might need to learn about standards. We may need to learn about disabled access in buildings. There's plenty of things in our industry we need to learn about. So it's important that we do training constantly. So here's a tip. Here's something I learned. Are your CAD users CAD geeks? Well, I found when I tried to implement training as a CAD manager, I'm a massive CAD geek. So I wanted to teach everybody everything. 1 week I'd show them one technique, 1 week I'd show them a different technique. I'd show them all the different features their software could use, and I just confused the hell out of people. I could not believe it when I realised that some of my CAD team just wanted to come to work, do their work, and then go home and watch the football. So I had to learn that rather than train people in everything, I needed to find a process based on my CAD standard, find a process for how we did a task, find the best way to do that process, and then just train in that one method. And that worked much better because it was a lot less confusing for people. They found that shortcut of how to do that task. They didn't find some terrible shortcut. I made sure it was the most effective one. And for those guys who were a bit geekier, if they wanted to get more into the software or they wanted to try different techniques, that's fine. They could come to me and we would have fun messing around with it. But for some of my users, just establishing a process, teaching on that process was the way to do it. So what I've learned about training is firstly a little and often. So when you first learn a piece of software, you probably are best off going off-site, spending some time, probably your Autodesk reseller, spend 3 or 4 days learning how to use that software. You need some time away from the office to do that. You need to be not disturbed by emails, not disturbed by phone calls, not disturbed by meetings or people popping in to ask you questions, right? So you need to concentrate for a few days. You're learning something brand new. And for many people, they get that opportunity when they first join a company. So maybe you've been using SolidWorks and you come to a company, they're using Inventor. So you get 3 or 4 days to go off and learn Inventor, right? That's brilliant. But you'll never get that again. Because as soon as you get useful to that company and you get busy, they're not going to be able to spare 3 or 4 days of your time, right? They've got other things for you to do. So a little and often is really important. Once you've had that initial training in your software, it's important you have a little and often. The other thing is, if you train for 3 or 4 days, how much of that do you remember? Well, there's probably things you learned on day 1 which you forgot about by day 3. So by doing a little and often, you can really increase people's retention rates. They can remember what they've learned much better. And I also think training at the point of need. That's kind of how we expect to get things these days. If we have a problem, we expect it to be resolved immediately. We don't expect to have to kind of wait around for a solution. Okay, so if we have a problem, we'll Google it, we'll go onto YouTube, we'll go onto Autodesk forums, we'll find an answer. So if you're training within your company, if you can pre-record useful training content, maybe using something like Camtasia or like Autodesk Screencast, make a little training video or put together a PowerPoint or write a little document and put that on your SharePoint or on your server, or try and find some way to make it easy for people to find, then as they need that training, they can consume it when they need it. So if they need training in project setup, they're going to want it when they're setting up a project. If they need training on how to create content for your library, they'll want that training before they create the content. Okay, so rather than trying to do that stuff once a month and possibly be training people in things that they're not going to use that month, try and package your training up into training that can be taken at the point of need. I think there's an expectation for that these days, but it's effective. And I'll just reiterate that point: training one method only, and train to your standard. Okay, so understand what your standard is. Make sure you have your standard in place. Find those procedures that you're doing often. Find those the best method for doing them, and put together training documentation based on that one method. Not either or, just one way. This is the way we do it here. And be as specific as you can. Give examples of file names. Tell them where you want them to save the files. Be as specific as you can so there is no wriggle room. Okay, so let's review a little bit. These are the 5 core areas which I believe every CAD manager needs to be aware of. These are the 5 environmental variables, if you like, 5 tasks. So I know that we've got project deadlines to manage. I know that we've got people to manage. I know that all that stuff is important. But this is what I consider the key part of the CAD manager's job, is to provide the right environment for that stuff to happen in. So these are all the environmental variables. These are all the things that if you have a right environment, if you have all these things working, those day-to-day tasks get so much easier because you're not tripping over hardware problems. You're not having to make content on the fly. You've got the training you need. You understand your standards, all that kind of stuff. But I just want to give a little a different kind of perspective on that. So here I've mapped them out slightly differently. I've mapped them money against time. So if you're in a position where you want to get back to the office and you're thinking about, okay, so how do I start to implement some of this advice that Paul's given me? How do I start to look after some of these environmental variables? What's my low-hanging fruit, right? What's the biggest bang for my buck? Well, the reason I put hardware at the top of the list is because it's a simple investment of money. You can put money into that, and a successful company will have money. A successful company won't have time because you'll be busy. They'll be keeping you busy making money. So if we look down the list there, I've got content libraries right down the bottom of the list, because you can't really spend money on content libraries. Well, you could subcontract it out to somebody else, I guess, but most of the time your content library is going to be built in-house. And time is really difficult to find because your time is billable and your boss will want to bill your time against projects. Okay, because that's where you're making money for the company. So if you're looking for low-hanging fruit, I've kind of put them in the order here. Look after your hardware, look after your software. They're kind of the easy ones. Right bang in the middle here, we've got training, because training takes time and money. And I've put standardization a little bit down the other end of the tree there, because you can't really invest money in standardization. You can pay for people to come and help you write the standard documentation up or put the training material together. But the process of getting people on board and making sure people are willing to use the standard and willing to comply with the standard is time consuming. It just takes time. It can literally take a couple of years to keep the message going, keep the message on the table, keep people talking, discussing standards to the point where people are really willing to comply with them. So you can't give standardization enough time. You've really got to give that time to embed. So hopefully let's give you a little idea here about if you're going back to the office and you want to start putting some of these things into action about where your low-hanging fruit is. If you've already invested in software, hardware recently, then maybe look at software. If you've already got your software buttoned up, maybe look at training, and so on. But of course, this isn't a one-off process. This is not something you're going to be doing just once when you get back to the office and sorting out. This is something that's constant. So all of these things, it's not just a case of having a plan to get them implemented once. It's a case of having a strategy to be able to implement these things year on year. Okay, so we talk about hardware being on a 3 to 5 year cycle. Libraries are kind of constant. Software also on a 1 to 3 year cycle, depending on how frequently you buy your subscriptions. Standardization is going to be a lot of effort if you haven't got one right now, but it's going to be effort over time required to keep those standards up and keep it high. And training, of course, again, is something you need to constantly justify to management that training is needed. Training is actually one of the ways you can maintain standards. So you're going to train people in the standard. You can keep the awareness up there. The ultimate goal for all of this is automation. So once we have all these things in place, we can then begin to automate tasks for people. So if we can say to people, here's a task you do all day, every day, there are 5 steps in it, you always do the 5 steps the same way, we shouldn't be doing that, right? That's what CAD tools are for. CAD, computer-aided design, computer-aided design, I don't think that's a very good name for it, because does the computer really aid us in designing? Well, there's some new stuff coming through you might see in the next couple of years, but right now it doesn't really aid us in the design. We do the design, we've got the imagination. The computer can't imagine these things for us. The computer aids us with the documentation, and it aids us, if we go right back and talk about copy and paste, it aids us by automating our processes. So really we should be using the computer to automate that dull, boring stuff. Remember my story about having to create parts lists? We don't want to be doing that. The computer needs to do that for us. But the computer can't do that for us unless we're consistent in our approach. And that's why we need our standards. That's why we need our libraries. That's why we need all of that stuff in place so that we can teach our stupid computers how to do our work for us, so we can spend more time on the important stuff like drinking coffee and eating cake. The important stuff like optimizing our designs for our employer. Okay, so I'm nearly at the end. I'm just going to finish up with a little challenge. Here's my challenge to you. I didn't get to speak at Autodesk University because I'm the cleverest guy there. That's certainly not true. And I didn't get to speak at Autodesk University because I'm the best qualified, and that's not true either. I got to speak at Autodesk University because when the people at Autodesk University said, have you got something to share? I thought, I have. I think I have got something to share. I think I've got something here that I can talk about that I think would be useful to people. So my challenge to you is, firstly, do you have something to share? Can you help your fellow CAD users? I think you have. I think everybody that watches this presentation will have an experience which somebody else watching the presentation would really love to learn from. Okay, so my challenge to you is your turn next year. Submit a paper to Autodesk University, come and have your turn, come and speak. It's a fantastic experience and I really encourage you to have a go. So we would finish here with a Q&A. Now we can't have a Q&A live because this is a pre-record, but I'm going to post this up on YouTube. Please feel free to pull out your comments. You can contact me Twitter at CADsetterout, and I'll be pleased to answer any questions or try and hook you up with people who can answer your questions. And if you did come and see this class at Autodesk University, please fill out your feedback survey. It's so important to us, and we really appreciate getting your feedback. So thank you very much. I hope you enjoyed the presentation. And if you see me at Autodesk University in the future, come and say hi. Paul Munford, CADsetterout.com. Thank you.